Okay, so 2 comma negative 1, final answer. Number 2, how did you start? Solving for z, by the way, substitution or elimination, I should. Substitution, and then some of you use? Yeah, it's just not a right or wrong, it's just whatever you like. If you use elimination, what 2 equation?
X plus 2y minus z equals negative 9 and x minus 4y plus z equals 1.
Okay, so you use the bottom 2 first. What did you eliminate? Okay, so that means you should have 2x, bless you, 2x minus 2y equals to what? Good. Now you have to eliminate z from another 2 equation. Which 2 did you use next?
X plus 2y minus z equals negative 9 and 2x plus y minus z.
Okay, so you use the second.
Oh, no, I used the third and first.
Okay, so I can't use the second and third again because I already used that. Okay, so third and first. So you use, the first is already there. I'm just going to move the third up here. 4y plus z equals 1. Did you eliminate z again?
Yeah.
Okay, so if you eliminated z, what did you get? 3x minus 3y, like that?
Yeah.
Equals to negative 1. Now what would you next? You have 2 variables, 2 equations, just like number 1. What's your next step? Sure. Which one do you want to eliminate? There's no right or wrong answer.
I got stuck here because
Sure. Which one did you try to eliminate?
I was gonna try to eliminate x with it.
Sure. Let's do x. So that means you're going to multiply this by 3 and multiply this by negative 2. Okay, let's do it. Ready? On the first one, what did you end up getting?
Oh, 6x minus 6y equals to
negative 24. How about this side? The bottom.
negative 6x plus 6y equals to 2.
Good. So we are going to eliminate. All x's are gone. All y's are gone. What's left on the left side? 0 equals negative 22. Class, is that possible? No. So what kind of answer are we going to have? No real solution. No real solutions, y'all. Because that's not possible. What if you solve all of it the same way and then you come out like negative 22 equals negative 22? What type of answer is that? All real answer. Infinitely many. You guys remember this? Okay, when they do not match, then there's no real answers. When they all match, like 0 is 0 or negative 22 is negative 22, that means it's infinitely many. All right, so that's how we solve those back in the day. We are now studying systems of linear equations, but using matrices. So the definition of matrix, let's go and do that. Raise your hand if you already know how to, well, how about this? Raise your hand if you've seen matrices before. And what class would that be? Just seen it? Okay.
But they popped up on like standardized tests like the SAT and the ACT.
Is that why you saw it? Did you know how to do it? No. Where did you see it? Yeah. Oh, nice. What did you see it, Evan?
Oh, ACT.
Okay. Did you guys know how to do it in the ACT? A little bit? Okay. Well, good news. You now will know how to do it, okay? Matrix. Is it too late now for ACT? No, right? You're going to take it again? Or, okay. Yes, I do like The Matrix, the movie, if that counts. All right. So, the definition of matrix is defined as a rectangular array of numbers. Each entry we're going to call it A, I, J subscript. So A subscript I subscript J. So each entry, A subscript IJ, where I is the row and J is the column. Okay, so an example of this is we're going to try to make a rectangular shape. It doesn't have to be a rectangular. A square is also a rectangular. Would you guys agree with that? Can a rectangle be a square? No, but a square can be a rectangle. Just like a circle, it's also an ellipse, but an ellipse is not a circle. Okay, so we're going to start with row 1. We will go to row 2. We'll skip a few. We'll call this row I, and then skip a few. We're going to call the last row M. All right, now we are going to do column. So we'll start with column 1. We'll go to column 2. We'll skip a few. We'll call it column J. Skip a few more. We'll call it column N. Okay, so for us to know exactly where it is, row 1, column 1, we normally say A1, 1. So the I is 1, the J is also 1. Row 1, column 2 is now A1, 2. So I is 1 and J is 2. So for this one, A1, J, dot, dot, dot. Last one, A1, N. Okay. So these subscript will allow us to identify exactly the location of this entry. Row 2 will be A2, 1. So row 2, column 1, bless you. Then this would be A subscript 2, 2. We're skipping a few. A2J, skip a few more. A2N. Okay, so that's what it means right there. Now we're going to skip a few rows. Now row I, I1, because row I and then column 1. This is row I. 2, skip a few. This is I, J, skip a few. This is A, I, N. Now we have one last row. We call it row M. M and N, just like I and J, we don't know where it is. Okay, so this is going to be A subscript M, 1, A subscript M, 2. Skip a few columns here. A subscript M, J, and the last entry is called what? A what? M, N. Okay. Next definition is augmented matrix. So augmented matrix is a matrix used to represent a system of equations. A system of equations. Variables must be on the left side and constant are on the right side. So variables must be on the left side and constant on the right. We're just going to skip all the way down to example 1 because it says for us to write an augmented matrix. So example 1, write the augmented matrix of the given system of equations. What size? How many variables do we have on example 1? 3. Okay. So what do I mean by left and right? For this one, you're going to have a rectangle. You have the left. It's divided by this vertical bar. So all the variables, these right here are all of your variables. Those will be on the left side. So your first entry is 6. Row 1, column 1. Row 1, column 2, the next entry is a 2. The third entry would be a -1. Now the constant for this equation is 0. So 0 is a constant. It stays on the right. All the variables will stay on the left. Row 2, what are your numbers? What are the entries on row 2? 1, 1, 0. If it's missing, then you can write 0. What's the constant here? 4. Good. Last one, 2. What else? 0 and 5, and constant would be 2. That's an augmented matrix. We can go back and forth. Now, the coefficient matrix, most of the time, we don't really use the word coefficient matrix, but the book will ask you to write it. Its coefficient matrix is an augmented matrix with only the left side. So with only the left side. So that means you will not have that bar. So this one will be your coefficient matrix. You would only have 6, 2, -1, 1, 1, 0, 2, 0, 5. As you can see, we do not write the constant on your coefficient matrix. What'd you guys get for Christmas? Anything cool? Someone got a car? Anybody get a car? Or that's the question. Anyone got a car for Christmas? Okay, what's the next best thing? Oh, you got a Disney Pass? Wow. Now you have all theme parks now? That's all in California, right?
Except Universal. SeaWorld, not Six Flags Disney.
Where do you find the time to go to all of those?
I don't.
What's the next best thing besides theme parks? Any electronics?
Knockoff AirPods.
Are those like pieces, those things? Is that AirPods? The earpieces?
Yeah,
Knock off earpods, iPods. What is it called?
wireless
AirPods. Sorry, I'm old. I don't know these things. What else? Anyone got new phones? You got a new phone? Clothes. At this age, what do you want? Money? True, at this age, you guys probably have everything you guys need, huh? All right, just a few more vocab. Reduce row-echelon form. Here are the conditions of our reduce row-echelon form. There are 3 conditions, okay? Conditions are, 1, entry in row 1, column 1 is a 1 and zeros below it. So here we go. Entry in row 1, column 1 is a 1 and zeros below it, and leave a little bit space on the left because we're going to make an example right there, and zeros below it. That's condition number 1. Condition number 2. The first non-zero entry in each row after the first row is a 1, and only zeros below it. Any row that contains all zeros to the left of the vertical bar must be moved or appear at the bottom. So, last condition. Any row that contain all zeros to the left of vertical bar must appear or move at the bottom. Okay. So what does that all look like? When you get it all done, when it asks you to perform your reduced row echelon form, it says entry in row 1, column 1 must be a 1. So let's make this like 3 rows by 4 columns. That means there's zeros below it. Okay, that's what it says. So once you have that 1 class, the entries on the right side do not have to be 1 or 0. It can be, but they do not have to be. Okay, so that's the condition. Now that you have 1 there, the next 1 value would be here. And again, if there's a 1, you have to have 0 after it according to your condition number 2. The first non-zero entry, condition number 2, in each row after the first row is a 1 and only zeros below it. So that means I got A, B, so this is our C. Okay. Well, guess what the third value of that third row is? It's a 1. Okay. So you got your A, B, C. Now, your right side, these are your constants. So I already use A, B, C. So we can use D, E, and F here. Mind you that A, B, C, D, E, and F are all real numbers. That can be any number you like to use. It can be 0, it can be negative, it can be fraction, it can be decimal, anything you want. What's happening to the diagonals in your row echelon form? What's going on with these? They must be what? They must be all 1. Okay, so in the reduced row echelon form, they have to be all 1s. Inconsistent and consistent. Anybody remember these words at all in Algebra 2 or even in Algebra 1? A system that's inconsistent. Take a wild guess. Has an answer or does not have answers? Inconsistent. Something that's inconsistent. Answers or no answers? No answers, right, okay? Inconsistent is when the system of equations do not meet or don't meet. If they don't meet, do they have answers? If the 2 lines don't meet ever, would you have answers? No, that means no solutions. Okay. So that means consistent has answers or no answers? Yes. Okay. So consistent system of equations that have solutions. Now there are two kinds of answers. Okay. The first one, you're going to have one set of answers. The second one, we have infinitely many solutions. So tell me the difference in the two. So let's say you have, just like number one. Number one, is that infinitely many solutions on number one, the review? Or is it just one set of answers? One answer, one set. Okay, that's one X, one Y, so that's one set of answers. When do you then get infinitely many solutions? Yeah, but what's happening? You're right. It is all real. But when would you get it?
When all your variables cancel.
When they all cancel, you're right. So if I were to graph those lines out, what's happening to all the lines?
They all overlap.
Yeah, they are identical lines, right? Because every X and every Y would be exactly the same. So that's when you would have infinitely many solutions. Okay, so those are the difference. Example 2, can you help me read the instruction, Jean, to example dos?
Write the system of equations corresponding to each augmented matrix that perform the indicated row operations on the given augmented matrix.
Good. So I'm giving you a matrix. We're going to go backwards. You are given a matrix here. This is looks like 2 rows by 3. Okay. You are asked to write the system of equation. So what would you start with? How many x's, how many y's on row 1? 2x minus 4y equals to, that's right. Row 2 is 3x minus 6y equals to negative 5. Okay, so that's how we do it. That's how we go forward and backward. Now it says, okay, perform the indicated row operations. So let me tell you how to read this. You are giving 2 rows. This big capital R here, subscript 2, means you are about to change row 2 and only row 2 by taking negative 3 times the entry in row 1, then add the entry in row 2. Okay, so we are going to do this very slowly since it's your first time, and then I'm going to write everything out for you. Okay. Do we change row 1 at all based on this example? No, so we write it back. 2, negative 4, negative 4. Row 1 remains unchanged. Now we are about to change row 2. We will start with negative 3, because that's a constant they said for us to use, times the entry from row 1. What is the entry from row 1 of this column 1? 2, right? Because isn't this all the entries from row 1? Okay, so we're going to take negative 3 times 2. We are now going to add the entry from row 2. What's the value from row 2 from column 1? Right, we're about to add row 2. Aren't these a value from row 2? So what's that value? 3. So that's what we add. We will do another one after we simplify. Next, row 2, column 2. We will again take negative 3 times, what are we going to time? What? Negative 4. We are going to add the entry from row 2, which is what? Negative 6, you're right. Same thing with the constant. We will take negative 3 times negative 4 plus what? Negative 4, okay? I'm sorry, negative 5, I lied. All right, let's do the basic math, and then we'll write the final matrix. What happened? Did I do it wrong? Nope. Sometimes I do, so yeah, just tell me. All right, so this is your final answer. We're about to write all the entries in here. Row 1 will remain unchanged. Okay. After you do the basic math, what are the 3 entries for row 2? -3, 6, and 7. Confirm, Joe, for me. So right or wrong? Right. All right. And we can go on to example B. Example B, you are given a matrix with 3 rows. Okay. First, they want you to write it as a system. How many variables are you going to have? 3. All right. You can answer your question?
Can you explain why it goes from -4 to +4?
Where are we at? Right. Oh, I made that as a mistake. Thanks, sir. Yeah. That was a negative. Thank you. The row 1 cannot be changed. Thank you. Good eye. All right. So B. X, Y, and Z. How many X's on row 1? 2X. What else? -3. Y plus 4Z equals to -6. Yep. Next would be -5X minus 6Y minus 4Z equals to -6. Last one would be -4X minus 3Y plus 5Z equals to 8. Okay, so that's your system. Now this one, how many rows do they want you to change? 2 at the same time. Okay? And no, you don't have to do both at the same time. You can do 1 row and then go do the other. So this one, again, we are going to do it step by step. We'll start with a big matrix, and then we'll write a smaller one. All right. Row 1. Do we change row 1 for this particular question? Nope. So let's write it exactly the way that they had it. Okay. All right. How are we changing row 2, y'all? We take what? 2. We times it to entry number row 1. What do we multiply to? What's our entry from row 1? 2, yep. Then we add to entry row 2, right? Because this one says row 2. What's the value of row 2? Plus -5. Can I go straight to -5 if I want to? Yep. Okay. Same thing with this. Take 2 times -3. What? -6. You're right. I can go add -6 or just go -6. Then 2 times what? 2 times 4. Yep. And what else? -4. Perfect. Okay. And then the constant, we are going to take 2 times -6. And then what else? -6. We'll do the basic math after. All right, row 3. How are we changing row 3? Take 2 times 2, yep, plus row 3 item. What is row 3 entry?
4.
-4. Yes or no? Isn't this first? It's that guy. Okay, so I want to make sure we're very cautious, okay? Remember, the smaller r is the original. The big R is the new value from the changes. All right, do me a favor. I want you to fill in 2 more entries right there, or 3. And then once you have it all filled in, then I want you to write the final matrix. And then box that up. So Caitlin, what are your 4 entries on row 2, hon? Yeah, row 2. 2 times 2 minus 5. What would you get? -1. Keep on going. 0. Okay. Okay. 4. -18. Agree? Disagree? The 0 is not -0? I mean, the 0 is not negative. The 0 is not 0? What is it? -12. Is that all we need to fix? Okay. Now, I got 3 blank spaces on there, so that means it's not written. So hopefully you guys wrote it in, and then now I'm looking for the remaining 4 entries for the last row, okay? So Emma, can you give me your 4 entries for the last row?
0, -9, 15, -6.
Confirm, deny? I'm trusting you on this. No? No? This one's not it? So erase that too? Okay, so it looks like that's the 3rd entry. Okay, so did you do 2? Whoops, I didn't need to write eraser. 2 times entry from row 1, so that's 4. Add row 3. Row 3 is 5. Confirm that? Yeah? Okay, so that is 13? Yeah, okay. So as you can see, it's really easy to kind of like, your eyes are going to be in the different spots, so make sure we're very cautious of what we're writing. It's easy to make these mistakes, okay? All right, here we go. Can you help me read the instruction to Chris E, example 3?
The reduced row-echelon form of a system of linear equations is given. Write the system of equations corresponding to the given matrix. Use x, y, or x, y, z as variables. Determine whether the system is consistent or inconsistent. If it is consistent, give the solution.
Okay, so now just look at it. Give me a wild guess. Consistent or inconsistent?
Inconsistent.
So you think you won't have an answer?
Because if it's a reduced row-echelon, row 3, column 3 should be right.
Row 3, column 3.
Yeah.
It doesn't have to. Remember, one of the conditions says if everything on the left-hand side is 0, you have to move it to the bottom. So this is legit. Everything's left, right? So let's check it out. That's okay. I asked you for a wild guess. First, would you agree that it wants you to write it back as a system? So there's 3 variables. So we will do 1x. There is no y, but how many z's? 4z, and equals to 4. Okay, that's equation number 1. Equation number 2 has no x's. How many y's? 1 y. How many z's? 3z equals to 2. Would you guys agree? The third equation has 0x plus 0y plus 0z equals 0. Do I have to write that?
No.
No, it doesn't make sense for us to do so. So that's your final answer for your system. Now, what does this dude right here in the bottom? This guy in the bottom, this means z is any number it wants to be. Okay, that's what it means right there. Z, when you have a whole set of zeros, that means z is any number that it wants to be. If z is any number that it wants to be, remember, when you write an answer, it's an x comma y comma z. So we write z belongs to a set of all real numbers. That's an answer for z. Z can be -5. Z can be 1/10. Z can be whatever.
So why is it C specifically?
Because over here, as you can see, this is 1y and this is 1x. We're going to go backwards. It's easier for us to locate z than we go backwards to find y, and we go backwards to find x. Okay? So to find y, it depends on z. Okay? So we're going to take this equation and guess what we solve for?
Y.
So fall for what? To be continued tomorrow. Okay.